name is Eugene Cordero, and I am, as Barb mentioned, a professor in meteorology and climate science. So here I am, in case you can't see me in the little box. I do have a PhD. I'm a doctor, but I have this name given to me as Dr. Burrito. And part of what I'm going to do today is explain to you how that happened and relate it to this issue about climate change. So I started very similar to your trajectory right now at a Cal State University. I was at Cal State Northridge, and I was studying physics. So I'm going to share to you my journey from a Cal State through other places and then back to a state university, which I've been at for 18 years. So I started by studying physics, and I developed an interest in the atmosphere in particular. So then I went to UC Davis, and that's where I got my PhD in atmospheric science. And after getting my PhD in 1995, I went to NASA Goddard, to the NASA Goddard Space Flight Center, and I was in a group of scientists, about 100, who were studying ozone. And it was a wonderful experience, and that's where I did my postdoc. And then after that, I went to Australia, where I was a postdoc there as well at Monash University. Now, I know that some of you know geography. I hope you all realize that Australia is not a little country. It's not a little island like that. Australia is a big continent. It's about the same size as United States. But to get it to fit in the slide, I had to make it small. But I was at Monash University, and that's where I did work on both ozone, but then in climate change. And after that, I returned to San Jose State University, where I've been for 18 years. During that time, I have been studying the Earth, and in particular, climate change. And so that's what I'm going to share with you today, some background about climate change and my own research. So this is a map or a chart of global temperatures. This comes from land and ocean data. This comes from NASA, and it is a long-term record for the last 120 years of global mean temperatures. And you can see that the temperatures from like 1880 to 1960 kind of went up and down, but especially since 1970, the temperatures are trending in the upward direction. And although there might be a year or two where it goes up and down, that red line, which is the 5-year running mean, is very consistent. And so we're seeing a very steady increase in global temperatures. And this is quite unusual. We see the record of temperature here in data, but you can also see it physically. For example, this large glaciers in Norway in 1918 compared to today, and you can see a large amount of ice has declined because of that warming temperature. Here's another example in northern Alaska in 1922. And today, much of that ice is gone. Although what I find remarkable is that this little iceberg right here is still here more than 80 years later. Now that is, of course, that's a coincidence, that's a joke. But we can see the record from the NASA satellite image of the ice sheet today over the North Pole and what it used to look like shown here in this orange line. And so we're definitely changing the character of our whole planet. And in our lifetime, we are seeing a systematic change in our planet. And that's affecting us here at home, even in California. So this shows fires, it shows storms, and these are effects that are impacting our country. So in 2018, we had a number of billion-dollar weather and climate disasters. We had fires, we had heavy rainfall, we had severe hurricanes and snowstorms, kind of like we're witnessing today. 2019, we had more weather extremes. Again, we had very strong fires in California, tropical cyclones, severe weather. And then in 2020, this last year, we went through it was the worst fire season for parts of California. We have a drought here in the West. We have severe weather, and we had the highest number of tropical cyclones for a long, long time, and 22 separate billion-dollar weather disasters. And if you're thinking, oh, is this just in the last few years? NOAA, who keeps track of the National Ocean and Atmospheric Association, shows data here of the US billion-dollar disasters from 1980 to 2020, consumer price index adjusted. So we can see that these weather and climate disasters are costing us more money every year. And in fact, we're paying about right now extra $50 billion a year for weather and climate disasters compared to what we used to. So it's very clear that something is happening very dramatic, and it's costing us money and it's costing us lives. So one question that people could ask, is a good question, is how do we know what is causing recent changes in climate? And if you didn't know anything about climate, that would be a very good place to start. Well, we know that the sun is responsible for all the energy that we're getting on our planet. And we're going to talk about energy a lot today, but energy is kind of the key element in climate change. And so we do get all our energy from the sun. So maybe the sun is responsible for climate change, or maybe volcanic eruptions are responsible for climate change, or maybe there's other factors. And as scientists, we look at these things. In fact, I even had funding from NASA to study how small variations in the sun's intensity could affect climate. And that's research that scientists have been doing for many years. But what we have found as a scientific community, that this change, which is the change in carbon dioxide in the atmosphere. This is a record from Mauna Loa Observatory in Hawaii that measures carbon dioxide from 1960 or 1958 through to today. And we can see that the amount in parts per million of carbon dioxide in the atmosphere is going up. And because this is a heat trapping gas, this we expect on its own to warm the planet. And from a science perspective, if this was the only thing going on, then this would be pretty straightforward. But the climate system is very complex. And like many of the fields that we're studying in engineering or in math, you know, as you learn more about civil engineering or biomedical or about aviation or industrial systems, you realize, gosh, this field is complex. There's lots to it. And it's the same thing in the climate field, is that this is a very complex system, our whole planet. So to ask the question about, oh, what is the human contribution to our climate, we need to use various tools. And I'm just going to share with you one of these tools, but I wanted you to see that there are a number of tools that scientists use to study climate change and the human impact. I'm going to share with you something about this first one called radiative forcing, which is like an energy bookkeeping exercise. And the reason I'm going to share this with you is that as engineers, I think you might find this really helpful for your own engineering work. But then there's global climate models, which are like weather forecasting models. And there's this thing called fingerprint attribution detection and atmospheric measurements, lots of different ways that scientists use to study our climate system and to try to connect human activity with changes in climate. So I'm going to start this by presenting a thought experiment for us. And that thought experiment goes like this. How does auto exhaust affect the climate? So here we see this car, we see this exhaust coming out. If someone said, oh, what impact does this have on climate change? And I think we'd all agree like, oh yeah, this is bad for our climate. But it turns out that if we were to analyze the exhaust inside, like we take some instruments and look at like what's coming out of the tailpipe, we'd actually find two things. We'd find carbon dioxide, which is a gas, which is heat trapping, and so that would warm the planet. But then we find visible aerosols like that. This smoky stuff that you see right here, those are actual particles in the air. They're not a gas. Remember, gases are invisible, like carbon dioxide and water vapor. But these are little particles that are floating around. And if you notice their color, they kind of light color. And it turns out the sunlight can hit that light color aerosol and bounce back out to space. And so it turns out that this aerosols are actually cooling the planet, and the carbon dioxide is warming. And I, and probably everyone else, wouldn't really know which one wins out. So it's actually more complicated than you first anticipate. So that's why we're going to use this radiative forcing technique to help us answer questions like this. And as engineers, you can answer other questions that you might have about solutions. So here's how this, I'm going to show you one kind of crazy graph today, and we're going to spend a little time on it. And then I'm going to give you a quiz and see how you do. And So let's see if we can follow along with this. But this is a really useful tool for understanding the climate system. So what these measurements or estimates do is they tell us how do different factors in the world contribute to warming or cooling of the planet. And that's what's called a radiative forcing calculation. So for example, the first two things here, carbon dioxide, methane, NO2, nitrous oxide, halocarbons. These are all gases in the atmosphere that have increased over the last 250 years. And this radiative forcing, it takes today's system compared to pre-industrial or 250 years ago. So we say, oh, today there's more CO2 in the atmosphere, and that's going to cause the planet to warm. How much? Well, in watts per meter squared, like 1.6 or 1.7 watts per meter squared of extra energy is hitting the surface of the Earth because of extra CO2 in the atmosphere. Or 0.5, that's what this red bar, this CH4, 0.5 watts per meter squared of additional heat is hitting the surface of the Earth because of additional methane in the atmosphere today. And methane comes from human activities, could come from cows, I mean, the various sources. But what this is saying is what's changed on our planet and what impact does it have on warming or cooling? And so, for example, greenhouse gases are primarily warming the planet by, between 0.5 and 1.5 watts per meter squared. And if you want to know what's that out of, we have about, 240 watts per meter squared coming in. So, this is a small percentage, but turns out it makes a big difference. Now, that's not the only thing changing greenhouse gases. We've also changed ozone in the atmosphere, and some of that ozone is at the surface, and it's kind of like pollution, and that's warming the planet. But there's some ozone in the upper atmosphere that's cooling. So there's two factors happening, one warming the planet, one cooling, but the cooling one's pretty small. Then there's stratospheric water vapor that's up in the upper atmosphere. And this is getting into the weeds a little bit, but this radiative forcing calculation this is what scientists use. So I wanted to show you, what we use in the actual science field. Then there's albedo, and albedo means the reflectivity of the surface. And we've been cutting down forests at pretty high rates. And it turns out that changes the brightness of our planet and allows light to be absorbed more or reflect away more. And it turns out that deforestation is primarily because the forests are dark in color and we've cut them down, the surface underneath is lighter in color, and that's actually cooling the planet. So the albedo change is a cooling factor. These aerosols I just showed you back in the car example are cooling. And you can see the uncertainty bars here. And that means we're not really perfectly sure how much it's cooling, but we know that aerosols are cooling the planet. And we know that aerosols also cause clouds to form and they cool the planet too. And then there's airplanes, and for the aviation folks, the little clouds that come out of the back of an airplane, they cause warming, but it's a tiny, tiny amount. There's been a whole bunch of studies on this, so we feel pretty confident in that. And then here's the sun. The sun actually causes the planet to warm. Now, these are changes in the sun's intensity over the last 250 years. And so the sun has been getting a little bit stronger, but it's still not nearly as large as these other factors. And in fact, when we add up all the anthropogenic or human factors, we can quantify them. So basically add up everything here, we see that the net impact is warming. So this is, for me, a very useful tool because I can start to quantify the impacts of these different human activities. And also I could flip it around, and if I wanted to solve some of these problems, I could see like, oh, if I could reduce the amount of aerosols in the atmosphere, like what impact would that have? If I could reduce the amount of CO2 in the atmosphere, what impact would that have? And you can ultimately turn this into money and into a solution that could drive an enterprise. Okay, well, I hope you're ready for a quiz. So I'm going to ask you a series of questions that come from this. I'll go through the questions, then I'll launch the poll. And something happened to my PowerPoint just now. So we will, but let me just, we came back. Just pause that for a sec. Maybe that's telling us that quiz are some people saying, oh, I really don't want that quiz. But I think we do want that quiz, and I think we're excited about that because since folks have been paying attention here, I think we're excited to see that. Okay, so here's the radiative forcing chart, and I'm going to ask you a couple questions. One is, what is the most important human activity contributing to climate change? What about the sun? Isn't that contributing to climate change? And then going back to this driving, is it good or bad? And so I'll leave this up and I will launch this poll right now. And you should see this, this poll come up. And I'll just give you, I'll give you about 45 seconds to answer these questions. And I'll launch the poll right now. And then after we close the poll, we're going to look at the answers and see how we did. And maybe if we did wonderfully, we could, let's see, what kind of prize could I give? Your instructors could give extra credit, but we have to do perfectly on it. Okay, I'll just give you another 10 seconds. Already 93% of people have contributed. So you've done a good job of answering, at least participating, and that's excellent. I'll end the poll in a couple seconds now, and then we'll take a look at the results. Okay, so let's look at these results. And I assume that you're seeing the results just like I am. So question 1 says, what is the most important human activity contributing to climate change? And most of us said that it was greenhouse gases. And I would agree too, that this here on the left side, you could add up 1.6 watts per meter squared, and then another 2.6 watts per meter, another watt per meter squared. So by far that is the largest part. Aerosols are cooling, not that they're not important, but we can quantify them here. And even deforestation is having an impact, but it's actually, it's cooling the planet. So we will talk about forests a little bit later, just briefly. Okay, question 2. So anyhow, we did a good job on that. What contributions does the sun play on climate change? Is that important? And so I actually put a value here. And so I said 0.15 watts per meter squared. That's basically the number here. If I was to look at the number here, it's about 0.15 watts per meter squared. Is that important? I guess that's there's a bit of a philosophical nature to this too, but from looking at this chart, it's not it's not critically important. It's not unimportant, it's a number, but compared to some of the other impacts, due to greenhouse gases or aerosols, the number is relatively small. So the human contribution is by far much larger if we look at the human contribution here compared to the sun. Not to say the sun isn't important, so I'm not going to say what's exactly right, but it's not nearly as important. Doesn't mean we shouldn't study it. And then what about driving? Is it good or bad for climate? Few people say good, some people said bad. And some people were neutral, and some people said need more information. And so I agree with many of these. It isn't, of course, good for the planet, and yet the cooling and warming factors, it's a little unclear like which one's really winning out. So these aerosols are cooling, but the greenhouse gases are warming, and we do maybe need some more information, like how long do these aerosols last in the atmosphere? What is the lifetime? And it turns out carbon dioxide lasts for quite a few years, sometimes 100 years in the atmosphere. So you emit some CO2 and it stays in the atmosphere for 100 years. Aerosols only last for like 2 weeks. And that's why when it rains, the air becomes clean. All those aerosols get rained out. And that's why when we put a catalytic converter on our automobile, it cleans it up and we can see the results quite quickly. So that's actually interesting that we can clean up these aerosols, turns out much easier than doing other things. Anyhow, I think we did pretty well on this quiz. Congratulations. I would encourage all your professors to be nice to you based on your results here. And of course, they're always super nice to you. We do care about our students here. So what are the predictions for the future? Well, we have some climate model simulations that show us what might happen to our planet in the future in terms of temperature. And we know the observations for the last 50 or 80 years, but we don't know what's going to happen in the future because we don't know what kind of cars we're going to drive. We don't know what kind of, where we're going to get our energy for factories, what our homes are going to be like. So this line, the red line, is kind of business as usual. Let's just keep emitting just like normal. And we can see that by 2100, we might be 5 degrees Celsius or 10 degrees Fahrenheit warmer than we are today, which is a lot. We have other scenarios based on other possible futures. And then we have one scenario where we actually stabilize our climate. And that's what the international community is really interested in, is to get on some type of stabilization. Now we saw the temperatures just rising, but we want to flatten that and eventually cool things back down. Otherwise, it's not good for our planet for various reasons. So how do we get on that green trajectory? Well, we're going to do things like, wind power, large scale offshore wind, local micro. This is an engineer who built his own urban wind turbine. We're going to have mirrors follow the sun and drive steam engines. These are already installed in Southern California. Electric vehicles, electric heating and cooling systems, bicycles. These are all, parts of reducing our energy use and shifting it to renewables. So I'm going to give you a 3-step plan for how to reduce emissions. And I think that you'll find this very helpful, actually, even in your professional life as an engineer or working in this space related to designing solutions to our climate system. So here's the 3-step plan. And if you remember one thing from today, I hope it's these 3 steps. First step is to reduce energy demand. So make your system, whatever that needs energy, as efficient as possible. Step 2 is to electrify everything. So electrify transportation, electrify heating and cooling, basically make everything so that it can be plugged in. And then the final step is to get your electricity from renewables. So I'm going to show you some examples of what this looks like. And I think it's helpful to see, this practically speaking. We can say these 3 steps, but I'm going to show you what this looks like for a house. Now, this isn't any ordinary house. This is my house. This is where I live. And my wife and I, and Claire, my wife is one of the instructors in 100W, so her students are here as well. So now her students know where we live, or at least what the house looks like. So we decided to use this 3-step plan to try to make our home as energy efficient as possible. So the first step is reduce energy demand. And that means to use less energy. And we figured out eventually when we looked at the data that it was stuff like this, like insulation, that actually is going to reduce our biggest energy user, which was our heating system. And all of our energy throughout the whole year, by far the biggest piece was heating. So we hired this company who basically blew in this insulation into our attic. They put it underneath the home, and then they drilled holes in the walls, and they just blew that and stuck that insulation in the walls. Here's a close-up. And this insulation is like paper and blue jeans and cellulose material that has a high R value. And so, it was quite a job, but they did some good work. Now, I was lucky enough to have access to a $100,000 FLIR infrared camera from the Fire Weather Research Lab in our department. And I said, hey, can I borrow this camera? Because they're doing this insulation stuff, and I want to see what does it look like. And so I took it home one evening, and I started to look at the infrared emissions, and this is when they had all the holes. And so I could see like, oh yeah, here's where the hole is, and then they put this insulation in. And that was cool. And then you could see like, oh, they were still working on the attic space. And professionals use tools like this to look at a building envelope and to try to make it really energy efficient. And you could also point it at our general contractor and see where heat is emanating from, like under his armpits right here, that's a hot spot. But one morning, I saw this signal or this pattern. And basically what's happening, and this is one of the walls in our bedroom, and the sun was hitting it from the outside. And they had just half finished. So they had basically put insulation in here and then in this region, but they hadn't got to this part yet. And what was really cool is I could tell that there was a diagonal beam inside the wall that was preventing the cellulose from this region from falling all the way to the bottom. It just really stayed up near the top. So it's really cool to have that kind of tool. I thought I'd just share that with you. We also replaced our windows with dual paned, argon-filled windows that have a much higher thermal resistance to heating and cooling. So we did everything we could to reduce energy demand. Step 2, electrify everything. And the big thing was heating. So this was our gas furnace. And we got rid of the gas furnace and installed one of these mini split, these are heat pumps, and they're about 4 times the efficiency of electric resistance heating. And so we use those for our heating and cooling. We don't need much cooling, but for heating in the winter time. And then we also installed a solar hot water system on our roof. And so then we don't have to heat our water as much. And then we use an electric flash hot water heater. And so we basically are heating our water and heating our air using electricity. So we electrify everything. And same for gas, for cooking in the kitchen. So we have an electric stove. And then the final piece is get your electricity from renewables. So we then put solar panels on our roof. And so these are the solar panels, and then this is the solar hot water system that we have on our roof as well. And because of microinverters, we can monitor the efficiency of each solar panel. So I'm a data scientist. I study the climate system, so I'm interested in results. So here's the energy use of our home the first 2 years we lived there. And this is how we discovered that heating was the largest piece. So this is in kilowatt hours. This is energy unit per day. And so you could see on average, we use up to 40 kilowatt hours per day in the winter time. Summer was below 10, but winter was pretty high. After we did these 3-step plan, here's what our load looked like. So this is our energy use. So we were able to drop our energy use 3 or 4 times just by making our home more energy efficient. And that's primarily through insulation and heating of water. Here's another way of looking at that. This is over a number of years. And then, so, we really did significantly change that. And then we have our solar, and we're producing energy primarily in the summertime, but producing some in the summer as well. And so here's our energy use around, between 6 and 9 or 10 kilowatt hours per day. And then here's how much energy we're producing, up to 20. So we're actually overproducing. We did buy an electric car a couple of years ago, but even so, this was the last year. This comes from PG&E, and you can get this data too from your PG&E account. This shows the last year of energy use. So in the winter time, we are basically drawing energy from the grid, but in the summertime, we're delivering more energy to the grid. And at the end of the year, PG&E will pay us money for the extra energy that we produce. So we did do this 3-step plan, and we even got a little bit of recognition, which is kind of fun. Silicon Valley Clean Energy, that does energy, not San Jose, but all the other cities in the South Bay here, is under Silicon Valley Clean Energy. And they featured our home. We have a 780 square foot home. It's a small home for Claire and myself, but we were able to showcase what we did because of this 3-step plan. And we even got to write up the 3-step plan so that other people could hear about it. And they gave us a lawn sign. So now we have this lawn sign, award-winning all-electric home. And I like this. In fact, it was our suggestion that they could make a lawn sign because it helps other people like see, because you just look at this house, you don't know that it's any different. But actually, we've reduced our energy use and we're actually a net producer of energy. And we were actually lucky to get a check or happy to get a check for $3,000 for being, I don't know, an innovator, even though we did this like 10 years ago. So they're just kind of like, we're just catching up and understanding this. So that's an example of how you might apply the 3-step plan. Now, as a climate scientist, I was thinking, okay, it really is clear what's going on with our climate system and what we should do about it. So it kind of generated the story in my own mind. I'm going to read to you this story, and it starts like this. Once upon a time, there was a scientist named Eugene. That's me. And every day he studied the climate system. But then one day he noticed the planet was warming. And because of that, he tried to figure out why. And he looked at this and he investigated that until finally he figured out that human activities were the primary cause. And after sharing the evidence with fancy plots and nice colors, people and policymakers changed their ways to reduce the causes of the warming planet. Hooray! We had a happy ending. Now, some people might call this a climate fiction story because it's not really what's happened. Even though we have all this amazing technology today, I just showed you a chart that shows the temperature continuing to go up. Even though over 200 countries signed the Paris Climate Accord and agreed to reduce carbon emissions and to try to stabilize climate, last year carbon dioxide concentrations in the atmosphere were the highest ever. And this chart that I showed you before, which for me is really scary, all those trajectories are really dangerous for our planet. And this one stabilization, we're not anywhere close to getting there. So the question to me really became how to solve this climate crisis. And it reminded me of, how do we solve problems at all? And there was this nice documentary called The Dalai Lama Renaissance. And in this movie, it documents how some US-based scientists and researchers thought, if we just put the best minds together, we could solve any problem. We could solve hunger and poverty and issues about homelessness. And we just need the best minds. And so what they did is they brought together the best 30 minds that they could find. And they said, but we should go in the presence of the Dalai Lama. Because, what if we went to India there and we were just in his presence and we had the best minds and we did a workshop, we can solve big problems. So this documentary documents or describes all these people, and they fly over to India and they put themselves in the presence of the Dalai Lama. And it's an interesting exploration of them trying to solve these challenging problems. But it turns out the first time when they meet with the Dalai Lama, they said, we're here to solve the greatest problems. And do you have any advice? And his advice was, you should look within yourself first. You should solve your own problems first. And they had been bickering about who's going to actually meet with the Dalai Lama, who's going to sit closest to him. And there was all this internal conflict. And so it reminded me, like, if I had the chance to speak with the Dalai Lama, who is someone that I really respect, and I said, hey, how do we solve the climate crisis? I could imagine that he might say to me, look within yourself. So I did. And this is what I found. I found burritos. I do like burritos. It's my favorite food. I verified that because I created something called a burrito enjoyment index, where I compared my interest in burritos compared to the average American. And I was able to document with data that I am, that's my thing. But it's, I'm not the only one who likes burritos. If you've heard of the group 538 that tracks national polls, probably a lot of us were looking at the 538 website before the election. They also focus on other important topics, like In Search of America's America's Best Burrito. Nate Silver, the founder of 538, seems to be a burrito enthusiast and did a whole bunch of analysis around burritos around the country. He calculated the VORB, very familiar with people, value over regular burrito. And he found that California is the best state, is the best region for burritos in the country. Yay! I chose the best place to live. So, and also they did a burrito bracket with 64 taquerias going down to 2. And they did a lot of, there's a whole bunch of things to read, but you can find the top 10 burritos in the country. And number 1 is El Favorito on 24th and Mission in San Francisco. That really spoke to me because I have been there. Look at that beautiful thing. Here I am with the El Favorito burrito. And so yes, I'm into these. So this is my favorite food. And every time I see this photo, I smile. I just love it. But it also, because I'm a climate scientist, I started to think, like, what impact is my addiction to burritos having on the planet? And so I did some burrito calculations where I calculated the carbon footprint of a chicken burrito and I compared it with a beef burrito. And oh my God, I was surprised. This beef burrito was like 5 times higher carbon footprint than the chicken burrito. And I got the opportunity to co-author a book about food and climate change and tell stories about burritos and other things. And ultimately, it led me to think more about, how to share some of these stories about issues related to our environment with more different audiences. So here at San Jose State, we have an amazing group of scholars and practitioners and students like yourselves who do care about the environment. So I started to work together with storytellers and artists and educators and engineers. And we wanted to tell stories about the environment and about solutions to the environment to younger audiences. So when I was thinking about how to solve the climate crisis, to me, education played a big role. And I wanted to create a type of education platform for young people. So about 10 years ago, we invented a superhero and a storyline called Green Ninja. We started making animated and live action films. We started making games and started to develop educational materials that kids could use to learn about issues like climate and the environment and about what they can do about it. And some of those films included Dr. Burrito. Here I am at a taqueria, and I'm calculating the carbon footprint with my burrito meter of 2 different flavors of burritos. Here's another one. This you've probably never seen, a burrito farm. This is where burritos grow. Look at the roots. I just pulled this one out of the ground. It's a really deep-rooted burrito. And I was, again, trying to understand, the environmental impact of burritos. Now, of course, that's just kind of silliness, but that was the approach we used for these films, was to try to make them interesting and engaging for younger audiences to start to see the relevance that humans are having on our planet. Now, the issue of food and climate change is complicated, and we could talk about this for a while, but here's the carbon footprint of 1,000 calories of different foods. And we can see that beef is by far the highest. And so going back to that carne asada versus a veggie burrito or a chicken burrito, it really makes a big difference. But there's lots of other stuff going on here as well. So it turns out that in general, animal products have a higher carbon footprint than vegetables by a lot. But even within animals, poultry meat is 5 here, and this is 35, about 5 times higher. And then there's even differences between we have cheese, and we have the vegetables and fruits. And we're learning more and more about the connection between food and climate change. Okay, so interesting stuff. Time for a burrito quiz. So let's see if you've been paying attention to this discussion, important discussion about burritos. I'm going to launch another poll. And this poll is critically important. Question 1 says, where's San Jose best downtown burritos? And then question 2 is, you're on a date. Let me read question 2, so listen up. You're on a date and want to impress. So you head out to your favorite taco truck. You find out your guest cares deeply about climate and the environment. Which ingredients do you suggest for your shared burrito? And you can choose more than one. So build your own burrito there tell me what ingredients you want in there. But remember, your date cares deeply about the environment. Don't mess up. And I'm going to tell you, I'm super interested to see the best downtown burrito place. And right now, I'm watching the results come in, and it's going to be good. Someone said you forgot to add the extra avocado option. I apologize. Zoom only allows 10 options, and I had to be extra avocados is a good one. And I'm seeing other burrito places coming in the chat too. Okay, 10 seconds and we're going to finish this up. Build your burrito. Five, four, three, two. Gosh, we get a lot of burrito suggestions. Okay, so I will end the poll and I will share the results with everybody. So Lavik got 24%, Iguanas got 10, Super Takati at 11, and then all burritos. Oh, thank you so much, everyone. All burritos are wonderful creations that we should care deeply about. So interesting. And then you're on a date and you want to impress. So we see a lot for rice and beans, and then some chicken or maybe grilled vegetables, cabbage, lettuce, eggs, avocado. Which one got the most? Avocado. Number 2 was, oh no, the most was rice and beans. Okay, rice, beans, avocado. Pretty much from there, you could add anything. I will say that I'll tell you as Dr. Burrito, I'm not a huge fan of lettuce. If you have a hot burrito and you put lettuce in there, it's going to get all mushy. I usually tell the taqueria, like Lavik, I have a vegetarian burrito, which is my preference. No lettuce, please. Cabbage is fine. Lettuce. But anyhow, we will continue. So this is all fun and interesting, although food is a really interesting topic. But I wanted to share lastly some research that I've been involved with here at San Jose State. And we published a paper last year where we looked at the role that climate change education could have on individual lifetime carbon emissions. And the kind of headline for our work was that high quality climate change education can be as effective in reducing carbon emissions as other solutions such as rooftop solar or electric vehicles. And we were able to identify the kind of key pieces that really have an impact on education. And we quantified the role that education could play compared to other solutions if adopted at scale. So climate change education, if scaled appropriately, could be just as impactful as electric vehicles or offshore wind. So folks, including myself, have been involved in this type of research. But what we're really finding is that human capital, knowledge and leadership and inspiration are critically important. And San Jose unveiled their climate action plan a couple of years ago. And here's what it looked like. Transportation, energy, buildings, food, water, all super important things. But I mentioned to Sam Liccardo, Mayor Sam Liccardo, and I said, Sam, your climate action plan is great, but it's missing one key piece. And he said, oh, what's that? And I said, education. There's no humans in here. Like, we need to inspire the public. We need to inspire youth. And that's what our work is at Green Ninja. So we started we basically transitioned from a research program here at San Jose State. We still do research here, to a purpose-based enterprise. And we are California Benefit Corporation. We started in 2016. We got our curriculum, middle school curriculum, adopted by the state of California in 2018. And we have customers in California and in other states and even in other countries who are using our curriculum approach. And I just wanted to share that this academic work that we do sometimes transitions and becomes these teacher editions or school books or materials kits. And ultimately affecting students' lives. So what does all this mean for engineers? And I know not every single person in here is an engineer, but we'll just use that frame. There is change ahead. And your engineering field, all of our engineering fields are changing and will continue to change. And I think that change is going to only accelerate. And so that's why I think understanding about climate and energy and those connections is important. For example, a growing number, and this only happened in the last couple of years, a growing number of countries have now net zero carbon targets. Net zero means that they are going to be like our house. They're going to be an energy producer. They're not going to emit extra carbon into the atmosphere. Brazil, Canada, China, EU, New Zealand, South Africa, South Korea, United Kingdom, and most recently, United States. We have a new president, and climate change, out of the priorities, COVID-19, of course, economy, racial equity, and climate change, those are the top 4 priorities for our country right now. And that's the first time climate change has ever been a top priority for our country. The Biden administration took already like 50 actions on climate change so far. Here's just 5. They rejoined the Paris Agreement on day 1. They're reducing methane emissions in the oil and gas sector. They're establishing fuel economy standards or reestablishing them for vehicles, revising appliance and building efficiency standards, identifying new opportunities for clean energy technologies and infrastructure. You can see how this is really engineering. It's almost all engineering related here, except the first one, which is a policy. Further, General Motors announced plans to end sale of gasoline cars by 2035. Our biggest car company says that by 2035, you can't buy a gas-powered car from them, and expect other companies to follow. And last week, Elon Musk announced a $100 million gigaton scale carbon removal, X Prize. You've probably heard of these X Prizes. These are these prizes for innovation, like launch vehicles into space, like super energy efficient light bulbs. This X Prize is to suck carbon out of the atmosphere. $100 million for this. This is what drives innovation. So I have one final question for you. I will launch this poll. So the question is, from this talk, what message did you find most relevant to you? What did you find most relevant? There's no right answer here. Just if you had to choose one thing. Give me 10 seconds, please. I see a couple people mentioning nothing about burritos. I was on the fence about that, but we're gonna stay focused here on what we're burritos are important, but so is climate and the environment. Okay, I'll end the poll, and we will look at the results together. So what did we find relevant? 7% found the science of climate change, engineering connections to climate change, about a quarter, the 3-step plan. I guess that was the winner. Connection between climate change and food, impact of climate change, impact of education, what the government's doing now, and how climate change may affect our personal or professional life. This was what I somewhat expected. And I wanted to mention that I think engineers are going to play a central role in shaping how we respond to climate, but from very different perspectives. Like, this is such a big issue that I'm not surprised that we all have different things that we bring to this, because this is related to our real world life. It's related to our profession. So here's the kind of summary. Greenhouse gas concentrations in the atmosphere are increasing. That's causing climate change. That's causing these impacts, these storms, the sea level rise, all this stuff. And we have to figure out how to adapt to those changes. And that's called adaptation. And that's in bridges, that's protect us from sea level rise, that's to protect us from extreme heat, rain. Going to be a lot of engineering work in that space. Mitigation, what to do about climate change, how to reduce carbon from the atmosphere, how to suck it out of the atmosphere, how to prevent it from going into the atmosphere. I would say that every area of engineering is going to see some element of climate change and the goal of creating solutions to climate change impact your area. Whether you are designing integrated circuits or some type of microprocessor and you want to reduce that energy demand because you want to save battery, or you're building a bridge and you want to use lower energy concrete. You are working in the field of designing more efficient production systems. You're in an airplane and you want to fly further on fuel or maybe even move to biofuels. All of these subject areas are being impacted by this drive that now our country is deciding, okay, we're going to take this very seriously, like other countries in the world. So I hope that this was a good introduction for you for this 100W class, and hopefully for your own professional lives in thinking about Earth and the environment, but also thinking about climate change and its connection with energy, both at the personal level, but also at the professional level. So thank you for listening, and I'm happy to take any questions that you may have.
Dr. Cordero, I have a question.
I'm ready.
I was wondering why you put such an importance on electrifying your home instead of other sources.
Sorry, can you say that again? Just broke up a little.
I was wondering why you picked electrifying your home as an importance first. I'm assuming that ties into renewable energy sources, and you have to have that to be benefit.
Okay, so you were wondering why we focused on electricity. You know, this three-step plan, the general idea of a three-step plan is that you, if you can electrify things and produce that electricity with renewables, then, you know, like we don't use the natural gas, we're not burning a fossil fuel, we're not putting carbon into the atmosphere. So, and you can imagine driving a car. If you can drive an electric car and get that electricity from renewables, from wind or solar, then, you know, you really made a change in terms of carbon emissions. So even if you don't have solar panels right now, the grid, this San Jose's grid and the whole of Silicon Valley's grid has become so much cleaner in the last few years because of the state's ability to put more renewables on the grid and to buy renewables from other states. And that's what that Silicon Valley Clean Energy, it's called a community choice aggregator. And they basically buy energy, renewable energy in bulk, and they distribute it to their users. And San Jose has a program like that too. So so we're moving in that direction. You can see the renewables coming in California. And the one thing that's left, that's missing, is transportation. Transportation's 64% of emissions in California are coming from the transportation sector because we've cleaned up the electricity sector so well. So that was the reason that we used that as a way of guiding what we did in our home. And we're not the only ones. That's a very common strategy. So thanks for the question. Do we have some other questions?
I have a question. So do hydrogen gas cars, is that like a popular idea coming up? Is that better for the environment in the long run, or what is your take about that topic?
Yeah, a few years ago, we had GreenTalk speakers here in this 100W class talking about the hydrogen economy. Arnold Schwarzenegger talked about that a lot. And the Japanese, Honda and Toyota both invested heavily in hydrogen. So hydrogen is it takes energy to make hydrogen fuel, but you could use that energy from renewables, and then that would make sense. And then the emissions out of the car is only water vapor. So it is a technology that makes sense. It hasn't gained a lot of traction here in the United States. Japan has moved in that direction more. The key piece is you don't want to use coal to generate your hydrogen. Like that hydrogen doesn't just come from nowhere. It needs to be generated. So if we're going to use hydrogen, which is a good option for some situations, then we just still need to think about where we get the hydrogen from. But I think we will continue to see more development of hydrogen as well. But probably electric vehicles are going to be, at least that's what it looks like right now. Now, we had someone from the California Air Resources Board a few years ago say, no, we think hydrogen's going to be the big one, but that was like 7 years ago, and it kind of hasn't really grown very much.
Yeah.
Thanks for the question.
Right. I think nuclear is not considered a renewable energy, but what's your take on it being like to replace a large majority of current non-renewables?
Yeah, good question about nuclear. It is, we don't consider renewable because we probably only have 100 years of uranium, or maybe 500 years that we could mine from the oceans. So it's not a traditional renewable, but some people do consider it a transition fuel. Once you build the reactor, it doesn't emit carbon, so it makes sense. It delivers energy quickly. There are some negatives, of course, and that is, potential for leaks. What do you do with the waste? So we might have some folks here who really think that nuclear, or maybe fast breeder reactors and more advanced nuclear power, might be a really good transition fuel for us. And I would say that makes sense. These are the kind of debates that I welcome, that I smile, that I say, yes, let's have these debates. Not the debate about whether climate change is happening or is because of humans. Let's try to figure out what the best way to solve this problem. And nuclear is certainly one of the candidates for sure.
Can I ask you a quick question? I agree with you, like for electrifying everything, but what you did in your house seems very expensive. Obviously, you have the money to afford it, but how can this be attainable for the average citizen?
Yeah, it's a very good question. When we bought our solar panels 10 years ago, they cost $4 per watt or something like that. And now the price has come down. So the first folks who go into this type of area are going to pay more, early adopters, but with scale, the prices are going to come down. And then that's one piece to it. The other piece is policy. So by I think it's already now in California, in the next couple of years, we will not build any new homes with natural gas. Just not going to happen.
That's already law.
Is that already law? Yeah.
Yes, it is.
So you see there's a policy push, and then then we need to follow that with low cost or reasonably cost appliances and infrastructure. And California has a cap and trade scheme with some other states. And that's where there's a movement called revenue neutral carbon tax. What that is that we start to tax carbon emissions, and you take the money from the tax and you give it back to people, so that it's not growing government, it's actually redistributing of money, so that lower income communities could afford the higher price for electricity, which is one of the results of a tax. So those are economic and political tools that are being explored, and those are the things, those are the conversations we need to really have. Is like, what's the nuts and bolts of doing that? That 3-step plan, you're right, that's a conceptual model for how to do it. What does it look like practically? Who are the winners and losers? How do we distribute this so that all communities can do this? That's where, if you look at a city like San Jose, you can see them trying different things. It'll be really interesting to see what that looks like. So thanks for that point.
Dr. Cordero, I was wondering, I read this article not that long ago that were stating that they did like research on like CO2 in the atmosphere. They stated that like the temperature of the earth became even hotter, even though we had less CO2 in the atmosphere. What would be they said that there was a process between like CO2 helps cool the atmosphere by, I forget exactly how it was, but could you explain?
Well, there's lots of different, like I showed you with that radiative forcing chart, there's lots of different factors that are causing our climate to change. And that was focused on human ones. Then there's all these natural factors that before humans were around, our climate was really, really hot or really, really cold. And there's different reasons for that. Some of them we're still learning the detailed nature of that. But I would say that what we have learned is that as we put extra carbon dioxide in the atmosphere, that there is that warming factor. We see that very clearly in the data. There may be some other things happening too, like maybe we get more clouds and that helps cool the planet. Those are called feedbacks. and they can accelerate the change or they can reduce the change. It's a complicated system, and it has also, unfortunately, become highly politicized too. And so as good readers and as good critical thinkers and science thinkers, when you go online and you read things, you want to be good you want to do some good critical thinking. I'm fairly conservative as when I look at science, just like most scientists, we want to see a collection of data, a collection of models and observations before we start to think, oh, maybe that's really true. So you could send me, maybe share it in the chat or something, that the link to that, or share it with your professor. And I'm happy to take a look. I love looking at some new ideas, or maybe that's an old idea that's come back. The science is not over. We're still learning, but we basically got 90% and we understand. I think we can hand it off to the engineers and the policymakers and the innovators and other folks to say, okay, this is really happening. Now, what should we do about that? How do we respond to that? But
yeah, I was just curious. I was just curious because this past year would be a really good process of really, because like there was such like a decrease in transportation and people being out of jobs, like, so we definitely came to a lot of stop in the world. So I was just curious if they had better, or like come up with different models or something.
Yeah, that's a really good point. And we even did a little study here where we looked at the transportation and the air pollution. And we did see a reduction in air pollution, but just for a few weeks, kind of came back. And for those of you who drive around, you notice, well, this 880 is still pretty busy, as it's not a complete freeway all the time there. They're still getting traffic, but we did see a dip in our carbon emissions. But we're still on this positive trajectory. And so we haven't, we did recognize that 2020 was a dip. But we're still putting, it's kind of like a piggy bank. If you have a piggy bank and you put, 3/4 in every day, but you only take one out, the piggy bank's going to grow. And that's what's going on with the carbon is we're putting so much carbon, some of it comes out naturally, but it's still, even if we don't put quite as much in, it's still growing. And that's still adding to more warming. So maybe time for one more question, and then we can, I know because Barb wants to end this, and then I'm happy to hang around here for a few more minutes in Zoom if other people have questions. But is there one more question?
Yeah, I have a quick question for you. In light of kind of how you were showing how even those things that we've been taught traditionally may or may not be an adder to climate change. When you were mentioning how deforestation is actually cooling the planet as opposed to warming the planet, even though that's kind of been something that's being taught in the opposite direction. I want to ask you to dive a little bit deeper into the use of electric vehicles, because initially, yes, it's a carbon cutting in that we are not using traditional gas, but however, with the proliferation of electric vehicles, aren't we only substituting just the mining of lithium in order to do that?
Yeah, so
so the mining of lithium will be creating as a significant amount of carbon being put back into the atmosphere?
Yeah, so that's an excellent question. And what's your major?
Electrical
Okay,
engineering, but I used to work for some.
Oh, cool. The reason I ask is that I imagine that there's some ISE, industrial and system engineering majors here, and that's what they do. Like if you go, oh, what's that major, ISE? They're looking at the full life cycle of, for example, a battery that goes in a cell phone or goes in a car, or you could take the whole car. Let's say you take an electric car and you do the well to wheel, or you basically try to figure out, like, does this really make sense? And that's what we want. That's the real approach we need to take to all these solutions, is like, okay, we have a gas car, here's its life. You have to build the car, you got to mine the gas, you got to do all this stuff, and then it burns, and then at the end of life, what happens to it? And now you do the same for an electric vehicle. And so we've been doing, we have done those type of analyses, not me, but our community has. And although there are, and then it gets even more complicated, because that lithium, is in another country, and like, there's some politics and some policy. So there are trade-offs, and there's no silver bullet that's like this perfect thing for everything. Like, there's trade-offs. So from a carbon standpoint, definitely you get back your carbon, even investing in the batteries, in about a year. So if the car is going to last 10 years, after about a year, if you drive 10,000 miles, your carbon savings is, you become into the positive, your net saving energy, even with the batteries. Although, because what happens to the batteries at the end of life is another story too. But you might not just look at it from a carbon standpoint. You might be looking at it from an urban pollution standpoint. You might be looking at it at a social equity standpoint. There's all these different ways to look at a process. And that's what the folks at Industrial and System Engineering look at. And we have a climate science major in meteorology. We have them take ISE 103 because it gets them to start thinking along those lines. So the long answer to your very good question is there are trade-offs. I still think that electric vehicles make sense, but we're going to have to do a better job of taking care of those materials, of reusing them. And it's not just like perfect. It's a trade-off. And we do think it's better, but it's, and going back to, the last thing to say is about the deforestation. From a reflectivity standpoint, cutting down forests cools the planet. But it turns out that that cutting down our trees, especially in tropical rainforests, is probably one of the worst things that we can do, because those are places that take up carbon from the atmosphere and provide important habitat for plants and animals. And so again, it's another question of like, oh wow, we're seeing these competing demands, and that is the position that I hope that we as a country and as a society can be debating. And we might have different opinions and different strategies, but if we have the same intention, and that intention is a clean and healthy planet for us, for our children, and for everyone, and we have equity built into all of that, so that there's not just wealthy people doing well and poor people suffering. If we can agree that that is our goal and that we share that common value, then I think we can really make progress. And I believe we're making steps in that direction. So thank you everyone for coming, really. I appreciate, I'll have to catch up on the chat. There's a lot of good Taqueria references that I need to make sure I investigate carefully. But also good luck the rest of the semester. And if you have climate change questions, or you can always find me on the meteorology and climate science. You can find my email, and I'm happy to stick around for a few more questions if people want to come up. But thank you everyone. And I'll turn it back to Barb if you wanted to say anything, Barb.
Oh, I just want to say thank you. Yes, thank you to you for a great presentation. A lot of good information. And yes, feel free to stay on. We'll keep Zoom open. If people have more questions, that's great. Students are in the chat saying thank you.
Thank you, everybody.
So, But yeah, we could stay on for a little while.
Thank you. Have a good day.
Anybody else want to ask a question directly to Dr.?
I do have a question. What's the perfect burrito?
I think that the La Vic breakfast burrito, rice and beans, potato and eggs, is as close as I've found, because the orange sauce is great, and you can put the amount of orange sauce you want on every bite. And the green sauce, actually, I like to put those together. So for me, that's pretty high up there. But I have to say, I'll tell my wife, oh, it's so great. But then I go to some other taqueria and I think, well, that was a pretty great burrito too. So maybe I'm not the best judge. But that's kind of my take.
I have a question about is O2 production the direct opposite of CO2 reduction? Like if you have a place that produces a lot of O2, like I don't remember where I saw this, but I saw like the U.S.'s Great Plains with like where we do most of our agriculture. The middle of the country produces more O2 than the rainforest and stuff around the world.
Well, when photosynthesis is this amazing thing that takes carbon out of the atmosphere and produces O2. So wherever you have photosynthesis, you're going to have that production. That prize that Elon Musk is sharing, he's looking he wants, and you know, his kind of view of the world is like, let's just invest in like technology and see if we can figure this out. So they basically want to do photosynthesis, but at scale without growing trees. I mean, trees are great. Planting trees makes so much sense because that's what it's doing. It's taking carbon out of the atmosphere and giving you oxygen. I mean, it's a wonderful thing. But can we, and we've had GreenTalk speakers a few years ago come and propose, oh, we got this factory in Palo Alto, we're pulling carbon out of the air and we're making carbon fiber stuff, but none of it is provided, none of it's shown an economic benefit. And if it doesn't make sense financially, it's not going to happen. So we need to rethink that. And that is definitely going to happen in engineering labs. I'm pretty sure whether we're going to be successful and whether it's going to be a cost benefit to build these carbon sucking technologies, I don't know. But maybe agriculture, maybe growing some certain foods might also be, and then there's this whole thing with soil, which is really complicated in roots. And that might be the Great Plains thing you're mentioning, is that deep-rooted prairie grasses seem to be good sequesters of carbon, although the rainforest is as well too. And it's hard to measure those things too. So sorry for the rambling answer.
Do you know if Elon will be paying that prize out in US dollars or Bitcoin?
Oh man, in Doge.
Yeah,
Doge is a joke.
Yeah, that's a good question. It said US dollars, but and you know, you have to take everything Elon does with a little bit of grain of salt, although he is like, I'll have to say the most impressive thing he ever did was land those two things at the same time. You know, those two booster rockets land at Cape Canaveral. It's like a sci-fi movie, and I was like, that's pretty cool. But I'm happy to see that, you know, we need that incentive for innovation.
I have a question for you.
Yeah.
What is your take about the alcohol industry and its waste to the environment?
Well, you know, I'll be honest with you. I don't know. Is there certain particular areas of waste? Do you mean in the manufacturing of alcohol, or do you mean in the packaging, or?
So the breakdown of the resources. I know that you then use the sugar, and breaking down sugar itself, it's a lot.
Yeah. I know that, you know, you could, gosh, I'm trying to think how to answer this best. There are opportunities for us to improve all of our industrial sector. And that's, again, going back to those, thinking about a life cycle analysis. For example, Apple went through the production of their, you know, of their phones or something, and they try to find out where are we using the most energy. And then that, because that correlates to where are we spending the most money. So going to your question, you know, maybe what we need to do is find uses for some of the byproducts of that alcohol production. Those are going to be probably natural fibers, that could be composted, but maybe they could be used for insulation, or maybe there's other forms. In Australia, they actually use a byproduct of beer manufacturing for a spread on, you know, for Vegemite or something like that. So, you know, there are other, and even like if you ever ate Total cereal, you know, that cereal, the Total for Breakfast of Champions kind of thing, you know, there's iron in there, and that iron came from some industrial manufacturing system that produced these little filings. And they said, what are we gonna do with these things? We'll just throw them in the trash? Oh no, let's put them in some people's cereal and fortify cereal. So, you know, perhaps there's an opportunity in the alcohol manufacturing area, to see what can we do with this? And a friend of mine runs a company called World Centric that uses bagasse fiber to make cups and plates. And he's built a $100 million company out of that. He's not the only one, but that is all like pure engineering entrepreneurship kind of come together. So if you have some ideas about, or if you have an interest in that, I'd start to look at that. I don't know anything about it, but it sounds interesting.
Thank you.
Thank you.
Yeah.
Oh,
Hi, Doctor.
Oh, I think there's one more question. Go ahead.
Yeah, this one really, I think you mentioned about the education that have an impact on the climate change. I think you probably put the integrated into the, I think, footprint of San Jose states. So did you see the impacts on those educations? And then how do you measure it actually?
Well, that's a good question. We surveyed students many years after they had some educational experience at San Jose State. And we asked them a bunch of questions to see like, what was their life like now? What kind of car did they drive? What kind of food did they eat? And then we compared that number to the average Californian. So we were able to quantify based on just survey results. We just give them a survey, but ask them a whole bunch of questions about their lifestyle. And then we compared that to the average person in California. And that is what allowed us to get an estimate. It's not the perfect, there could be some, we might be off by some, but what we were trying to document is that that sometimes educational experiences, if well crafted, can have a long-lasting impact. Like we hope this 100W class might have. You might get some ideas here in this class that follow you for many years, and you might create a company, you might innovate in your manufacturing or in your engineering field. And that's what we were trying to document. We know that happens, and we were trying to quantify it in some measurable way.
Okay, thank you, Doctor.
Oh, thank you.
So, okay, everybody, why don't we go ahead and end here? Again, thank you, Dr. Cordero, for a great presentation and for staying on to answer students' questions. Students, we will have slides available. You need to, you should be able to get them from your instructor. And also, we want to be sure that you join us next week and the following 8 weeks, the following 6 weeks after that, since we will continue to have Green Talks up until mid-April. So everyone, thank you, and hope to see you next week. Bye.
Bye. Thank you.
Thank you.
Have a good day.
Thank you.